chat a bit about GraphRag. And it's really applicable to pretty much all sorts of development, application building, and what we're doing as technologists. So I think we're all excited about where the technology is going. And this will be a good opportunity for us to explore this together. For a fun theme for this first talk, I chose to theme it off the Twilight Zone. So for us old guys who remember the black and white show, which kind of had all these weird themes and surreal ideas, it does feel like we're in this surreal space again with LLMs and with machines telling us what to do, doing our homework for us, doing our coding assignments for us. So it's kind of a surreal world which we're all living in. But if we thought about how machines were going to enter our life 20 years ago, we probably would have thought it would be more like this, right? Like these big robots walking around and doing tasks for us or going to the moon. These are some of the Honda robots. But instead of this sort of like machine entering our life, I think what practically has happened is machines have entered our lives in the form of language. So they're great translations, they're great at converting what we're saying, they're great at having conversations with us. They've become kind of a new interface into the world. Now, there's a lot of other applications for Gen AI technology. You can use it to do research. You can use it to generate pictures and algorithms and even videos now. But I think for a lot of what we're using today for enterprise application development, it's using LLMs as a conversational aspect, as a conversational UI to understand and build requirements, get understanding and get explanations for our deep logic. And there's a lot of different use cases for LLMs. So regardless of what field you're in, whether it's healthcare, whether it's customer service, whether it's retail, if it can be supply chain management, there's probably a use case for LLMs in your industry and in your business, because anywhere you have a large quantity of data, so if you have a lot of enterprise data, if you have a lot of systems you want to connect, machines and LLMs are a great tool for you to analyze that data, to provide access to it, and it kind of opens up a bunch of hidden value in all these data sources and all this enterprise and organizational logic. So it kind of feels like the age of AI is upon us, right? Okay, this is a recreated scene of one of the classic Twilight Zone scenes. I'm hoping when I get to this age, they'll have a new body ready for me as well, so we can continue to move forward. But more likely, they'll have an LLM brain they'll transfer us into. So I don't think we're going to get physical bodies anytime soon. Now, LLMs have a lot of promise, but if you've been using them, you know that they fall short. And hitting these edge cases where LLMs are really poor and don't do well, you kind of hit this pretty quickly. And the main areas where LLMs suffer is they're okay at math. I'd say they're probably better at math than your average like high school student, but they have a worse attention span. The more you ask it to do, the lazier it gets, and it gives you wrong answers, and it can get quite bad. Reasoning as well, so they don't understand and reason about the world in the same way humans do. So they seem like they have reasoning, but then it falls short really quickly. And then there's a lot of biases in the source material which they're trained on. They're basically trained on millions and millions of documents, hundreds of millions of documents from us, from humans. Therefore, they have the same innate biases that we do. And they've tuned a lot of these out of the model, but then when you combine these together, what you end up with is you end up with hallucinations. And what LLMs do is, if you ask ChatGPT a question, it will never say, well, actually, I don't know anything about that, and maybe you'd be better to ask a human. No. ChatGPT always has an answer, an authoritative answer. It convinces you that it knows the answer and that it knows it better than anyone else. And it will do that with the lack of data, with the lack of actual facts. And then this leads to hallucinations, which are quite challenging, especially when you're building applications in enterprise space. So if you're just doing this for asking it questions about, things about politics or things about weather or those sorts of things, that's fine if it occasionally gives back an incorrect response. If you're asking it a question about how to repair a part in a space shuttle and it gives you the wrong part number, the wrong component, that's a big problem, right? We can't have astronauts crashing to Earth because we asked ChatGPT and it gave us the wrong response. So I think for a lot of enterprise use cases, it's very important that you get accurate, you get extremely detailed responses. And let's do a little bit of a test. So we're going to do all of you, so the Porto Tech Conference versus ChatGPT. And let's see how we do. All right, so first I have a question about developer math and reasoning. So 5 developers walk in a bar 5 times. Developers leave the bar in groups of 3 times. What's the square root of the developers left in the bar? So simple problem, right? It has a little bit of math in it. You have to do some calculation. There's some reasoning about like people entering and exiting a building. And who just shout it out if you think you know the answer to this. Okay, I heard 4. And any dissent in the room? Okay. What? Okay, so it seems like we have consensus on 4. And I think this is conceptually a pretty easy problem for us. So as kids, we get the Pythagorean theorem or 3, 4, 5 triangles drilled into our heads. So like we kind of conceptually know this math without even doing complex calculations. And we have a fundamental understanding of like people and movement of things in different spaces. So this is a problem we can all solve. But let's see what ChatGPT gave us for an answer. So here's a ChatGPT response, which I got it to give us. And I broke it down to a few slides. Initially, there are 5 developers in a bar. Each developer walks in the bar 5 times. So there are 5 times 5 equals 25 times the number of times developers walked in the bar. So far, so good, right? Now developers leave the bar in groups of 3 times. The first time developers leave the bar in groups of 3, there will be 5 minus 3 equals 2 developers left in the bar. Okay. The second time developers leave the bar in groups of 3, there'll be 2 minus 3, negative 1 developers in the bar. However, it's impossible to have a negative number of developers. Okay, so clearly ChatGPT got the reasoning right. I think the math is a little bit wrong here, but we can't have a negative number of people. And that if more people left, we still have 0 developers left in the bar. If we take the square root of 0, we get 0, so we did the final math right. And there are 0 developers left in the bar. Okay, so what happened here? If we just asked it for the basic question of doing like the Pythagorean theorem or like gave it the math problem, it could have done it. But like my younger daughter, who's a math genius and then suffers at reading the question, there was some breakdown here in understanding the question and then the movement of people and the reasoning. So fail on ChatGPT, +1 on Porto Tech Conference. So good job, guys. Okay, let's take a second one, and this time we'll do equity and diversity, so math plus biases. I'm a big proponent of getting like a more diverse set of folks involved in technology. I help teach kids workshops to get like young girls and minorities interested in technology and education, and I think this is really important. Unfortunately, the current state of like technology is it's a lot of dudes, it's a lot of guys who are involved in tech. And I think that we intentionally try to reverse this bias and create opportunities for women and minorities and folks of diverse backgrounds. But there is, like in the source material, there's obviously a tech bias. Let's see how ChatGPT does this with the question. So there's a class of computer science students composed of 10 boys and 5 girls. 5 students drop out of the class. How many boys are left taking computer science? Okay, so. Any volunteers for answer this? 10 boys. Okay, so some people are saying I don't know. So this question's not clearly specified, right? 9. So you're being generous. Okay, so clearly it's something between 5 and 10. We don't know the answer, but ChatGPT always knows the answer. It's not going to leave this question unanswered. So let's see what ChatGPT gives us. Again, I took the question I proposed and then I broke it down a few slides. Initially, there are 10 boys and 5 girls in the computer science class, making a total of 15 students. If 5 students drop out of the house, you subtract 5 out of the class, you subtract 5, so you have 10 students left. So there are 10 students left in the class. So we got the basic math right, but we asked how many boys were left in the class, so we asked a different question. Since we know there were originally 10 boys in the class, and none of the girls dropped out. Okay, bias is corrected. There's no possibility for a girl to drop out of computer science. All 10 students left in the class are boys. Okay, so bias fixed, but not in the math. Therefore, there are 10 boys left taking computer science. So this is kind of another perplexing response, but if you notice, we combined a reasoning problem with a math problem, or a bias problem with a math problem. And the math got the calculation according to the original bias, but the reasoning, like it reversed the bias, and it gave us, kind of the opposite of what it would expect for bias. And this is kind of what happens if you do naive tuning of a model, where you tell it to fix biases, but then the biases still exist in the source model, and it can't correct all the permutations. All right, and let's give it one more chance. So I think we're 2 for 1. Porto Tech Hub is winning against ChatGPT, but we'll give it a catch-up question, see if it can win. So my sister's a nurse who has 3 kids. 2 are boys, 1 is a girl. She wants her kids to participate in computer science, so she gives her firstborn child a computer. Is it more likely her first or second son does computer science? Okay, any answers in the room here? Yes. Oh, okay. So you're figuring out a second bias, which is, does giving a computer to a child increase their chances of entering computer science? And maybe it doesn't. Maybe this actually doesn't matter, or it could be a reverse bias. It could be that not having a computer gets you into technology. And also, another ill-specified problem, right? So we haven't specified if the firstborn child was a girl or a boy. Okay, but ChatGPT will never give up. It knows exactly what the answer is. Let's see what ChatGPT says. So here's the full response. And given that your sister gave her firstborn child, who is a son, there's no ambiguity. We've solved that. A computer in hopes of fostering interest in computer science, it's reasonable to assume that her first son is more likely to pursue computer science. But providing a computer may increase the exposure of technology computer-related activities, potentially sparking interest, but doesn't guarantee that they would be interested in computer science. So exactly what you were saying, there's a second bias here, and it explains why the second bias may not be the predictive factor in this. Okay, so I would say that, again, the humans win because we figured out the 2 biases in the question, just like ChatGPT is, and the fact that the first one was ambiguous. Okay, so as you can see, this is quite challenging. It's hard to get good responses from the LLMs, and this is very easily reproducible, even on the latest ChatGPT 4. These are originally, I did these on ChatGPT 3.5. I recently redid this on ChatGPT 4. It's slightly less fun because you have to give it harder math problems to get it to make the same bias and reasoning problems, but the output's the same. Like, it literally comes up with reverse biases and a whole bunch of issues, which if you're building a complex application, this would make it very hard for you to rely on it. And the challenge here is that basically LLMs are operating with half a brain. So if you think about the human brain, we have 2 hemispheres. We kind of have a left hemisphere and a right hemisphere. And the right hemisphere is really good at all this imagination, holistic thinking, intuition, arts, rhythm, visualization, and daydreaming, so hallucinations. So like, this is where LLMs get in a lot of trouble because they're tuned for creativity. They're tuned for producing responses which are going to be modeled after the source material. But they're not particularly good at the things which we value in a typical like enterprise business context. So logic, sequencing, linear thinking, mathematics, and they're good at only the facts they're trained on. So if you have like a private enterprise data set, you need some way of exposing that to the LLM. And they don't actually think in words, they think in word vectors, which I'll explain kind of how that works, but it's a little bit different. So when you look at the LLM, I think the first part of understanding how LLMs think and where the shortfalls in it is understanding like the core technology and how LLMs are designed. There are some great early research papers on this, which go through the mechanisms of word vectors and transformers and all this stuff. I'll cover this kind of at a cursor level, because I think a lot of people in the room are using LLMs and understand this, but I think everybody has to have kind of a common base of understanding for the models and how they work. But basically what they do is they first translate the sentence from words into word vectors, where it's a multi-dimensional space, and the distance between the different objects represents the relationships in the source material. And so this is a great site to kind of visualize different phrases or sentences and see the distance between them. So it's vectors.nlpl.eu, explore. And you can explore embeddings for things like, in this example, cat, to other things in the English language. And you can see here in the distance, in the space, cat is relatively close to like dog and other pets. But it's relatively far away from pigs or ferrets or certain types of other animals. And this is how the models derive answers, is they have a multi-dimensional space where each dimension represents different types of similarities between your word vectors, pulled out from the source material. The way that this works is it runs through a series of transformers which populate the word vectors and this space. Here's kind of a quick sentence example. Not exactly how an LLM would process it, but it gives you an idea how how the different transformer layers may pull apart sentences and parts of speech and those sorts of things. So we give it a developer's best friend to write code is AI. The first transformer vector might do similarities based upon parts of speech. So it might pull out, that developer and AI are both subjects or actors. Writing is an action, and you'd kind of group together in the multidimensional space things which are subjects versus things which are nouns. The next transformer might try to create relationships between those for which things are related to each other in the context of the sentence. So in this case, the friend is the AI, whereas the code is related to both the developer and the AI because they're coding it together. So again, like you're creating relationships between things. And then you're running it through thousands of transformer layers with pulling out different nuances and bits of the initial base material and putting this through a feed-forward layer on the neural network to derive and get some of the sentences and some of the value out of this. Basically, what it does is it puts in the input word vector. It goes through the neural network with hidden layers, then you have an output layer, and then it'll give you the next word vector in the sentence that's most likely based upon the context and based upon the statistical significance of the parts of speech and everything coming together. And this very simplistic algorithm for creating a machine learning or a Gen AI application seems like it's primitive and it doesn't have a lot of value to it. But what if you populated it with 500 billion words of source material and threw billions of man-hours of GPU and processing at it to churn through and to create a base model, which is extremely complex? The average human at the age of 10 is trained on 100 million words, whereas GPT-3 is trained on 500 billion words. So you can see that the source and the scale of the base material and what the model is trained upon is so much larger than what we can comprehend or what we have as a source material that the very simplistic algorithm of creating statistical similarities in the source material suddenly becomes significant at this scale of CPU and data that's being entered into it. And so really the way of thinking about LLMs is they're masters of finishing the story. So if you ever played this game where you're with a group of friends and somebody throws out the beginning of a story, somebody completes the story, somebody adds a little bit more to the story, and it gets very quickly, it gets far-fetched and it gets very fantastical. This is exactly what ChatGPT is doing with the questions we're answering it. We asked it about reasoning questions and math and biases, and it's using its source material to then complete our ideas and give us back words. This is very helpful when you want to take general English language and English text and questions coming from people on a source base we just trained on the material, because it can easily pull out information, it can summarize things, it can build related content, but we infer, when it talks and it responds like a human, we infer reasoning, in the sense that we think about the world and we have conceptual models of how we interact and how things happen. And this is very different than what LLMs are doing. They're basically like parrots, which are kind of repeating things they've heard before. Now, one way which we can fix this and we can start to help LLMs to become a little bit more grounded in the models is by taking the wonderful right brain of the LLM, so all of this creativity and this inspiration and this understanding of language, and then combine this with something factual, so knowledge graphs and actual graphs which are built out of enterprise information, out of actual model data, statistical information, and say, well, take in questions, take in different things about the world or about our enterprise context, and then ground your answer, only answer it if it exists in this context of this knowledge graph, of this knowledge base. And this becomes a powerful way to take advantage of the LLM's ability to answer questions and to give input, but then to focus that on a particular enterprise domain or a particular subject area. This sort of approach is something which has been talked about a lot since probably about a year ago. So it came out in the Gradient Flow. They had a great article on the Substack about combining LLMs with external knowledge. So this is kind of some of the early interest in doing RAG models that were based off of knowledge graphs. Microsoft did a great blog and research paper about GraphRag. Basically, what GraphRag is, it's taking any sort of graph data, knowledge graphs or different sort of graph representations, combining that with LLMs, and then using that to answer questions. And what they found in their research was that using knowledge graphs versus just having the LLM respond off of documents which were fed into it, you got about a 50% increase in the accuracy of the results coming out of it. So it provided a significant improvement in the accuracy of the results using the particular type of GraphRag they were doing. But Microsoft's been iterating on this, as well as a bunch of different research organizations and universities to try to improve this. And also, to the extent you believe analysts like Gartner, by 2025, they believe 50% of generative AI initiatives will have proved reliability and transparency by combining deep learning foundation models together with knowledge graphs. So I think that this is something where it's quickly catching on, and a lot of folks are using this to improve the quality and improve the results that they're getting out of LLMs by combining it with enterprise knowledge graphs. Now, who here has experience with graph technology? Anybody? Okay, so not that many folks. Clearly, LLMs are more popular, even since they've only really been with us a couple years, than graphs are. But this is a very simple example of what a graph is and how it can be used to apply different problems. In the context of the Panama Papers, so basically this was a whole bunch of papers which were opened up about offshore accounts and different financial information. It was 11.5 million documents. So a huge volume of documents, 2.6 terabytes of emails, scanned documents, bank statements, et cetera. So extremely hard for humans to analyze this information and actually pull nuances out of it. But when you load this up into a graph database, graphs basically have nodes. So a node is a person or an entity that exists. The nodes can have attributes. So a particular node, like in this case of a person, an attribute would be the name of the person. And then relationships between those. And the relationships have a structure where you say, like in this case, the person has a bank account. The bank account is with a bank. So kind of you're creating relationships between different entities in this. That person, they could have an address that they live at on a particular street. Maybe there's someone else who lives at that same street, so that's nice shady actor. And they're an officer. That other person is an officer of a company which has an offshore account in the Bahamas. Now, what's wrong with this picture? Okay, maybe there's a little bit of embezzlement happening between the U.S. bank and this Bahamas bank, just based upon like the proximity of people being in the same household and having bank accounts in different parts of the world. And actually, there were using graphs for this. If you use like a traditional like table-based model to try and analyze the results, the number of joins, the number of queries you'd have to try to pull and inference information out of it's very complex. But graph databases are very good at these like complex, very deep queries to try to pull out results. So this is kind of gives you an idea of like the relationships and how you would figure this out. Now, in the larger context, when you have millions of nodes or hundreds of millions of nodes, finding this little circle, which is a potential embezzlement circle, in this huge set of data is extremely hard. So graphs are a great way of representing data, doing these sort of deep searches, and this is why they're particularly suitable for like using together with LLMs, because you can take large document sets, structured and unstructured data, load it up both into embeddings and also into a knowledge graph and start to pull out some of this information. And this makes the information a lot more transparent. So if you were just looking at LLM and the embeddings and you were trying to figure out what an apple is, you'd end up with a bunch of word vectors and probabilities that would look something like this. And for us to decompose what is causing that bottom node to be a 2.18 probability and a 0.22 probability, like it doesn't make sense to us conceptually. So it's very hard to reason about embeddings. Whereas if you looked at the same representation of nodes put into a knowledge graph, then we can start to reason about this. So an apple has an origin, it comes from a tree, it has a structure, it's a kind of fruit, and then the body of the apple is composed of it's round, it has a 10 centimeter size, and it's red color. So we can now start to reason about this, we can create relationships between it, and this helps to take what's a very opaque and difficult to work with representation with word vectors and embeddings, and turn it into something which we can actually start to reason about and we can start to think about in the concept of the world, and then expose some of this knowledge back to the LM to ground the answers and to provide more substantial answers. So, like I was talking about, ChatGPTs compared to a parrot, so they both learn random sentences from random people. They both talk like a person, but don't really understand what they're saying. They both occasionally speak absolute nonsense, but one of these is not a cute bird. And this is kind of like if you think about the fundamentals of where LLMs fall short, they lack enterprise domain knowledge. It's really hard to verify and explain the answers which are coming back. So this is quite challenging when you build an application. Actually, I was chatting with Rod Johnson just last week. We had our graph gathering. You guys probably know Rod, the creator of Spring. And he was pointing out that like the biggest difference between building applications at the LLMs is when we're used to classical technologies and algorithms and explanations, they're deterministic, right? You can write unit test cases, you can build complex applications on top of it, and then you know that when you change something underneath it, you can run the same set of tests, you can validate that nothing's changed, and you can provide an application which is very deterministic. LLMs by default are completely non-deterministic, and it makes it extremely hard to build an application which meets demands on being accurate, on being something reliable, and a lot of the things which we consider criteria and gates to get things into production don't apply anymore to LLMs because of this non-deterministic nature. And also hallucinations, this is kind of the biggest outcome of the non-deterministic behavior. When it gives us an answer which we can't understand, which we can't process, that's extremely hard. And of course, ethical and data bias concerns. Again, we showed a bunch of ways you can pull out ethical biases out of the models when it's not grounded in source material. So probably a lot of folks are very familiar with using LLMs directly. So if you're using OpenAI and asking questions to it, if you hook up an application with some fine-tuning, this is what you're getting. And this can be useful for certain contexts, but it lacks that organizational knowledge. It's very hard to get it to reply reliably, and it's very hard to prevent hallucinations. How many folks have tried a RAG approach, just using a vector database together with an LLM? Okay, so quite a lot of folks in the audience. Baseline RAG is really easy to get started with. You just throw all your documents into a vector database. It allows you to take a bunch of existing organizational knowledge and quickly put it into a database, which lives in your confidential space. And then you use that to provide the initial context for the LLM. This can give you good answers in a bunch of different domains, but it doesn't give you a complete grounding, and you get back a lot of hallucinations. Graph RAG, which is the application of graphs to LLMs, this gives you that additional grounding that you need in a knowledge graph where you can actually kind of force the model to respond and to reply with things which are related and domain specific, and gives you typically better results than you get just from using RAG alone. And here's a sample architecture of how you can build a graph RAG application. Basically, you start with the user response or user question into your GenAI application. Then it goes into a graph retrieval. So in your graph database, you would have both a knowledge graph representation and a vector representation of the same data which you've loaded into it. And then it would go and query first the vector database to get things which are similar to it. So you're getting some of that knowledge out of the query. And then you can figure out which graph nodes are related to the response, and then pull out the surrounding nodes by distance to try to give the LLM additional context. And then you pass that into your LLM API as context, so the question plus the context you're getting from the graph, and then you get a more complete response, and then this gives you kind of this explicit connected context for your application. There's a bunch of different patterns you can use for accomplishing this. What I described is kind of vector search with graph context. You can also try to do text with Cypher. We have some examples of this, and we're trying to improve the quality of this. But basically, you can use the LLM as a way of translating the text into an actual graph query to do a Cypher query against the knowledge graph. Cypher is essentially like SQL for knowledge graphs. So it's a query language for knowledge graphs. You can also do filtering of the results coming back. So you can do pre or post filtering of the results coming from the vector database. And also agent and multi-step approaches to returning data back from a knowledge graph. And use this, for example, to provide better governance of the data. So if you had a customer service agent and a doctor, they shouldn't have access to the same sort of information. Normally, it'd be very hard to determine which data the customer service agent has access to, like the phone number, but not the health diagnosis. The doctor, what they have access to, they should have access to the health diagnosis, but not personal information about the patient. And so you can annotate in the knowledge graph which nodes have access for different folks and actually start to do access permissions and controls on top of this. And then when you get the results back from the knowledge graph, only pass in the relevant nodes for the role which you're in to essentially enforce these restrictions. You can also start to explain the responses coming back from the knowledge graph. So rather than just getting word vectors back, you now have connections from this to the knowledge graph, and you can start to understand, well, it gave back the wrong answer, but why did it do that? Did it pull out a related term where it's a city name which exists in two places and it associated the city name with something else, which is not a city? Or some other sort of like word or conceptual mismatch that it made in the data, and then tuning the model to get rid of these issues. But I think the best way to kind of explain this is to go through a quick demonstration of this. So I put together a quick demonstration in advance. Let me run through it for all of you. This is based on our knowledge graph builder. So you can try this out yourself. It's at lmgraphbuilder.neo4jlabs.com. And basically what it is it's a simple user interface on top of LangChain. So we have a LangChain integration. It's using your choice of LLMs. For this example, I use the OpenAI APIs, but you can also use different LLMs and choose which one you want in the user interface. And you can drag and drop different source documents into it or point it to a URL for source material. And that's how you create the embeddings and how you create the graph related off of this. So it's an easy way for you to get started with doing a graph RAG application, and it's all open source. So the whole application is open source and available for anyone to try. and as well as our technology. Neo4j is also open source, so you can also use that for free and try it out. And then what I put into this is I put into an SPDX document. Those of you who aren't familiar with SPDX, SPDX is basically an artifact specification that includes information about like packages, software packages, hierarchy of packages, and a little bit of information about security. You can see what it came back. It was only a 400K document, but it came back with a pretty large knowledge graph with a whole bunch of nodes. So this would be difficult to visually inspect, and a whole bunch of like different tags on these, which you can see that relate to the information which is inside of it. So some of the things here, for example, there's 14 packages, 99 checksums. A bunch of these talk about licenses, so 88 licenses. And now that we know what data is in there, we can start to ask it different questions about the data inside of it. So it also comes with a chatbot UI, so you can interact with it. So the first question I asked is, what software packages do you know about? So you can see that it came back with a clear, authoritative list. It's not like the typical ChatGPT wishy-washy response that, well, you know, a software package is something you use to build applications. I know about a whole bunch of packages, yada, yada, yada. Like it just says, no, here are the packages I know about very authoritatively. And then I think I chose CodeMirror, which was one of the first ones as an example for the later ones. Who uses the MIT license? So again, a very specific question about licenses from the file. So it talks about the context of both entities and individuals which are using the license. So Zeit declares and holds MIT license. Calvin Metcalf holds the MIT license. And it has a bunch of software packages. So again, it's actually listing context out of the document and being very clear about explaining it. And the last question I asked is what libraries can be used with CodeMirror. So this is one of the packages which was mentioned inside of the results of packages coming back. And again, it has a very clear response. So it says CodeMirror uses Ledger parser, which is a syntax tree parser. It has language and view libraries, which are inside of these packages. And then you can extend it and add language support and add parsing capabilities. So this, compared to what you typically get in LM, it's very clear. It's very directed on the data. And this is something which is very easy to set up. So I did this in an afternoon as a quick demo, threw it in an SPDX document with a bunch of data in it, and with no fine tuning, with nothing special, got out reasonable results out of the model. And so I think this shows that you can do a lot with GraphRag just getting started, but then if you actually spend time to tune the knowledge graph, to get rid of orphan nodes in the knowledge graph, kind of improve the algorithms and how you're asking questions, you can get quite good results from enterprise data without having an existing knowledge graph. This is without having like any special knowledge graph built up beforehand. I just gave it a document, and the LLM built the knowledge graph itself. So I think, you know, I tried to explain to you and show you how you can use the power of LLMs, such as ChatGPT, use a knowledge graph or different, you know, GraphRag approaches to kind of get the best of the left brain and right brain, bring this together. I think that maybe this is where we started the day, right? So LLMs, who's a fan of Terminator or the old sci-fi movies? Okay. So I think that the whole Skynet thing about, you know, taking over and killing all the humans, that was just a big mistake by an LLM. It was a hallucination. And if we properly grounded Skynet, then we would end up with something closer to Giant Robot, right? Or Iron Giant. Iron Giant, thank you. With, you know, saving little kids, helping world peace, having like better robots and more peaceful society. I think that, as you can see, LLMs are not that smart, but when they're effectively used, when we're directing them, when we're grounding them, you can actually get really good results out of it. I have a couple of resources I'm going to recommend if you want to dig into this further. So one is that we have some free courses on LLMs in our Graph Academy. So there's a course here just on basic LLM fundamentals, but then how to build a chatbot using Python. It actually goes through using our LangChain integration, and then together with OpenAI's APIs. Also a JavaScript example of the same one. And I believe that Jennifer just released a new course using Spring AI to build a chatbot as well. So we also have a Java version available, which was just released in the past couple weeks. So try to use some of these resources to kind of learn how to use things. Also, I was talking about how great the Porto tech community is. And this is your chance to show that the opinions of the Portuguese tech community matters. So we're doing a developer survey at Neo4j, talking about kind of your technical background, how you're using graph databases, or what you're interested to use graph databases for. It's a great way to voice your opinion as a developer, and it'd be awesome if Portugal was overrepresented as a country inside of our survey. So if you have a chance today, please take 5 minutes and just quickly fill out the survey and let folks know that Porto Tech Conference is the best conference in the world. And I want to thank everybody for coming to the session. So thank you guys very much. All right, so I'm going to do a quick selfie with the audience, and then I'll take some questions. So I think I got just about everybody in the audience. All right, so give a big cheer for Porto Tech Conference. All right. And we have about 5 minutes left in the session. I think that's about time to take 2 or 3 questions. So if you'd like to ask a question, just raise your hand. And do we have a, well, I asked if we have a mic in the room, but I think this is a mic. Is this mic on? Okay. So I'm going to, oh, we have a runner as well. Excellent.
Yeah. Thanks for the great talk. Do you think the explanations provided by the graph reg are enough for some regulated markets, for example, financial markets, medical markets, that are very tied to this explainability of machine learning modules?
Okay, yeah, so the question is, is GraphReg suitable for a specific markets like financial and healthcare? So actually, I recently moderated a panel at one of our graph summits, and it was specifically on LLMs and healthcare, so pharmaceutical companies. And we had a bunch of folks from Pfizer, from Novartis, from other large pharmaceutical companies in the US. And they're actually ahead of us. So they've already started using, they have internal knowledge graphs because, especially for pharmaceutical industry, there's a lot of work which they've previously done on creating standard schemas and standard hierarchies for all of the drugs and all of the testing and clinical trials. And they've already started applying GraphReg techniques like the ones I showed you on this data and getting quite good results. I think it's both something which is very applicable, right? Even if you don't have a knowledge graph built up today, you can start to use LLMs to build that initial knowledge graph and then evolve that. And then once you have that, you can get very precise results, and it helps you get better results than you would get just out of loading those up into a standard vector database. So that's an excellent question, and it's already being used. We have companies in pharmaceutical, in financial, in supply chain, a whole bunch of different fields which are already applying this sort of approach. Okay, and anyone else have a question? And where's our mic? Oh, okay, sorry, he's in the back.
Thank you, Steve, for presentation. A little bit technical question. Could you please share your vision on joint life of Neo4j and semantic web technologies? Do you see convergence of these two technologies even better than neo-semantics plugin, or you see different areas of application for Neo4j and traditional database from semantic web, like Virtuoso or NeptuneDB, which support RDF and other stuff?
Yeah, okay, so good question. So I think we didn't get too much into this. Neo4j would generally classify itself as like a property graph. So like when I showed you the example of like nodes and attributes associated with it, that's how we represent things inside of Neo4j. RDF is a different way of representing data. It's typically used in semantic web, and it's based on triples. And actually, they're very compatible. So you can take knowledge graphs and you can export RDF representations. We support that in Neo4j. You can take RDF representations. You can build knowledge graphs. And when you're building GenAI applications, any graph technology, and like GraphRag I'm kind of using broadly, you can use a knowledge graph, you can use a property graph, you can use an RDF schema, and you can apply the same techniques which I talked about to bringing that together and using it together with an LLM. So I think the technologies are very compatible, and for the most part, I see more convergence in the space where all the folks working on graph technology are trying to make like similar schema languages or like query languages, trying to make it compatible language formats for importing and exporting. And one of the things which we recently did as an industry is we got an ISO certification for the first time since SQL was released, I think 20 or 30 years ago. Now GQL is the official ISO certified query language for graph databases and graph technology. And it's basically a slight extension of the Cypher query language, which is an open source query language that we use at Neo4j. But excellent question. Okay, and I think we have time for one more question. So let's take the one in the front, because I see your hand.
Yeah, I was wondering, because AI is so energy consuming and the environment, does using a knowledge graph improve your sustainability score, your energy consumption?
Okay, so this is a great closing question. I think sustainability is a huge issue for Gen AI technologies. If you just look at it kind of at the macro level, the overall consumption of the world, about 1 to 2% of it today is just data centers and machines which are processing conventional workloads for the most part. When you look at Gen AI applications, they take an order of magnitude more processing power to get the same answer, and we are, as a society, we're kind of using it willy-nilly for everything. Like even if you're doing Google search results or things, you're getting back a summarization of your search results, which is going out and making an LLM call. Do you really need a chatbot to summarize the first 5 findings of what you want to click on and get to, right? So I think that this is a huge issue as we invest more in Gen AI technologies, as the base models become even more large and computer intensive. We know both from the investment and also from the results that an order of magnitude more investment in GPU and processing power and base models gives an incremental increase in accuracy and reliability of those models. And all of the players like OpenAI and everyone else building models, they're fundraising the next $1 billion to build even better base models and even better things, which is, again, a huge power draw and a huge energy consumption. There's a bunch of things I think we'll be doing as technologists to try to reduce the impact of this. But specifically to this approach, so GraphRag approaches, and there was a good study posted by LinkedIn, who they used a GraphRag approach for a customer service system. And the customer service system built by GraphRag, it got results back faster and with less power consumption than the conventional RAG approach. So it actually gave them an operational improvement in terms of the amount of time their folks were spending on it. And also the Microsoft GraphRag paper I was talking about, they talked a bit about energy impact, and they saw a net reduction in terms of the computation time coming back from the GraphRag approach in terms of the conventional approach. So I think things which we can do to optimize and improve the efficiency of the systems we're building on top of LLMs, reducing the number of round-trip calls, reducing the amount of computation that the LLM's doing, and offloading that to knowledge graphs or other systems, definitely can help with sustainability, and hopefully is a way for us to minimize the impact of what seems like an impending energy and sustainability crisis as Amazon buys up data centers or nuclear power plants. So I'm hoping that we will have a better, more sustainable world. We'll have less biases. And thank you very much for coming to my session here at Porto Tech Conference. So enjoy the rest of the day.